Hello everyone, welcome to today's class. This is Teacher Simon taking you through SBO Mathematics paper 9709-13 for May, June 2021, and this is part 1 for questions 1 to 6. Question 1, a curve with this equation y is equal to f of x is such that its derivative is this. It is given that the curve passes through this point to 7. Find f of x. Of course, to get our f of x, then we shall integrate the derivative. So the derivative is 6x squared, then minus, this is 8, then x to the power of negative 2. Then with respect to x, we increase the power by 1, so that will be x power 3, then divide by the new power, then minus x, then x to the power of, increase the power by 1, it will be a negative 1, and then divide by the new power, then plus c. We have to put that c there because we don't know that constant which disappeared when they differentiated. Okay, so meaning our f of x is going to be 2, then x cubed, then here this one will be a plus, so that means we shall have plus 8, but using the rules of indices, I will take this one down, then it will be over x, then plus the c. If the point lies on the curve, then its coordinates must satisfy the equation of that curve. So if we have this point here 2, 7, its coordinates, the 7 has to be the y, and then the 2 will be the x. So I substitute them here, then 8 out of 2, then plus c. So this one is going to be 7. This one will be 16. So minus 16, that will be negative 9. This one will be a 4. So negative 9 minus 4, isn't that one negative 13? So c is equal to negative what? 13. So this simply implies that the expression for f of x, or the equation of the curve, will be 2x cubed, then plus 8 out of x, and then minus 13. That is that. The function f is defined by this, where x ranges from a half to a. It is given that f is a decreasing function. Find the maximum possible value of a. For a decreasing function, we know that its gradient is a negative. So for a decreasing function, thereof the dy dx, or for this case, since we are given f of x, then I will say that f prime of x has to be less than what? 0. It has to be a negative. So now we find the f prime of x here. So drop this power here. You have a third, then times, that is 3 over 2 into 2x minus 1, and then power 3 over 2 minus 1, that will be a half. Then times the derivative of what is inside here using the product rule, the chain rule, this one will be a 2. Then minus, when we differentiate here, we get a 2, not so? Then this one has to be less than 1, 0. So simplifying this one will go, and this one will also go with this one. So that means I'm going to have 2x minus 1, then power half, you see, then minus 2 has to be less than 0. You see, then I can take this on this side, and then we have 2x minus 1 power half, then less than 2. Then I can square both sides, not so? Both sides. So when we square both sides, automatically we shall have 2x minus 1, because this one will go, and then less than, square the 2, you will get a 4. So make this x the subject to the formula. We shall have 2x here, which is less than 5, and therefore x will be less than 5 over 2. Now if they give us a half less than x, then x is less than a. This simply implies that your a is going to be equal to 5 over 2. As simple as that. So the x values have to be greater than a half, but less than this one here. So don't you think the a falls in here? So that is that. Question 3. A line with this equation is a tangent to this curve. Find the possible values of the constant m and the corresponding coordinates of the points at which the line touches the curve. Now for intersection, I'm going to solve these two simultaneously. So for intersection, we shall have x squared minus the 4x then plus the 3, which will be equal to the mx then minus 6. So bring everything on one side such that we form a quadratic equation in x, and then we solve accordingly. So this is 3 then plus the 6 is equal to 0, meaning we get x squared then minus, I can put the 4 plus m inside here, then the x out, and then plus 9. Okay, now since this one is a tangent, remember when we are solving this quadratic equation, we are using x is equal to minus b, then plus or minus to the root of b squared minus 4ac out of 2a. Now, this discriminant here is the one that distinguishes between the nature of the roots that we get here. If it is greater than 0, that means we shall be in position to get the square root of what is here. You get it? And then we use the plus or minus. That is how we get the two distinct what? Roots. And then when this one is equal to 0, that means this whole thing is going to go. And then we remain with one root. We call it the repeated root, which is going to be minus b out of 2a. You see that? That is when actually the curve meets the line here at only one point. So that line is the tangent. So that is what we are going to use. B squared minus 4ac is equal to what? 0. If these two do not meet, that means this b squared minus 4ac is less than 0, because you cannot get the square root of a negative in the real system. So you are getting complex roots here. Okay. So for this case, because this one is a tangent, then I will say for tangency, b squared minus 4ac has to be equal to 0. So our b is negative 4 plus m. Then the whole of this, we square it, then minus 4. Our a is a 1, that is the coefficient of x squared. And then this one here is a 9, which is equal to 0. Now, when we square here, you square the negative, it goes not so. Then you square this 4 here, you'll get 16, then plus. Or I can actually just leave it here like this, and I say 4 plus m squared. And then 4 times 6, that is 36, which is the same as 6 what? Squared, not so, which is equal to 0. Then this is a difference of two squares. So I can have 4 plus m, then plus 6. And then here we shall have 4 plus m, then minus 6, which is equal to 0. So this is m plus 10, and then m minus 2 is equal to 0. So meaning the two values of m will be negative 10, and then the other one, 2. As simple as that. Because they said find the possible values of m and the corresponding points of the corresponding coordinates of the points at which the line touches the curve. Then we shall say for m is equal to negative 10, we shall substitute it here. That means we shall have x squared minus, this is 4 minus 10 of x, then plus 9, which is equal to 0. Which quadratic equation do we get here? This is x squared. This will be minus 6, not so. Then a minus 6 and then a minus here. That one makes it a positive. So plus 6x, then plus 9 is equal to 0. This is the same as x plus 3 squared is equal to 0. Because when you square this, you get that. Then 2 times x times 3. Don't you get 6x? Then square the 3, you get the 9. So from here, x will then be equal to negative what? 3. And they said coordinates. So after getting the x coordinate, then I can go for the y coordinate. So the y coordinate here is going to be, I can substitute here or here. So using the equation of the line, m is negative 10, then times the x I've gotten as negative 3, that will be a 30. Then minus 6, 30 minus 6, don't you get 24? Yes, so that means one of the coordinates is going to be negative 3 and then 24. That is that. Then we also go to the next one for m, which is equal to 2. What do we have? We have x squared, again substitute here, minus, we have 4, then plus 2, of x then plus 9 is equal to 0. This will be x squared minus the 6x plus 9 is equal to 0. This one will give us x minus 3 squared is equal to 0. And then, of course, from there, our x is going to be equal to 3. How about y? Y is equal to mx. The m is 2. The x is 3. Then minus 6. So this is 6 minus 6. Don't you get 0? That means the other coordinate, the other point is going to be 3. And then what? 0. So that is that. Question 4, part A. Show that this equation here is equal to A, where k is a constant, may be expressed as this. Okay, so we have tan of x, then plus the sine of x. We are dividing it by tan of x, then minus sine of x. So this one is equal to k. Now, since this one is still remaining as k, that simply implies that we are dealing with the left-hand side, okay? Tan is the same as sine of x, then we divide by the cosine of x, not so. Then plus, this is the sine of x here. Then again, out of this will be sine of x out of the cosine of x minus the sine of x. So this is equal to k. So we get one fraction here. This one is over 1. So we shall have sine x, then plus this one times this. You get cos x, sine x, not so. Then out of the cosine of x. Then this one will be over. Down here we shall have sine x, then minus cos x sine x, then over the cosine of x, not so. This one is equal to k. But when you actually try to look, since both of them are having the same denominator, that means the cos will go. Okay, so I'm going to pull out sine of x. It is common up here, but also with the cosine of x. That means here I'm remaining with a 1 and then a cosine here. So we have 1 then plus the cosine, not so. Then the same thing I'm going to do down here. I will have sine x here out of the cosine of x. Then inside here, I will have 1 minus the cosine of x. And of course, this one is equal to k. So do you see that this one is cancelling with that? So this simply implies that we shall have 1 plus cosine of x, then divide by 1 minus the cosine of x. So that will be our k. And this is exactly what they have told us to find here. Then part B, hence, meaning begin from where you have stopped, express cos of x in terms of k. So let us look at this. So 1 plus the cosine of x divided by 1 minus the cosine of x is equal to k. So we can cross multiply here. So we have 1 plus cosine of x. This one is equal to k, then minus k cosine of x. And then you make cos x the subject of the formula. So first get the terms that have gotten the cosine of x. So I'll make this one come this side. And it will add up to this one here, right? So cos x, then plus k cos of x, then is equal to, this is k, take the one this side, that will be a minus 1. And then I'm going to factorize out the cos x. That means here I have a 1, and then here I'm left with the k, which is equal to k minus 1. So meaning our cosine of x is going to be k minus 1 out of, because you are going to divide all through by this, 1 plus k, which I can write as k plus 1. And that is going to be the answer. Then part C, hence, again, begin from where you have stopped. Solve this equation here. Now, if we try to go back here, in part A, they're saying we had this tan x plus sine x. This one then is equal to k. Now, it is the same thing that we are having here. This is that means the k is equal to the 4. You see? So k is equal to 4. This one is already expressed in terms of this. And now, after expressing cos in terms of k, we are having this. So I will say therefore that cos of x, okay, shall be equal to this 4 minus 1 out of 3, no, 4 plus 1, not so? So this will be 3 over 5, which is equal to 3 over 5. So x is going to be the arc cos of 3 over 5. And then when we look at the 4 quadrants, we know that cos is positive in the first quadrant and the fourth quadrant. Okay, going anti-clockwise, the angles are positive, and then when we go clockwise, the angles are negative. So if there is x here, then the same x down here. So I will move here and also here. So when I move clockwise, I fall in the fourth quadrant. Okay, and then when I move anti-clockwise, I fall in the first quadrant, where cos is what? Positive. So this will be pi over 2, not so? Pi over 2, and then this will be now negative pi over 2. So the arc cos of this, I'm going to get the calculator is going to give me a positive value. But then, since we are moving from negative pi to pi, of course, this will be the pi, okay? Pi, when you are moving anti-clockwise. Then, when you move like this, by the time you come here, this will be negative 1, pi. You see that? So, I'm going to have negative pi here. So, if these ones were positive angles, like maybe from 0 to 2 pi, I would have taken this one here. Then I also move like this up to here. Then I will say the 2 pi here minus the x. You see that? But now since there is a negative here, then I have to just go clockwise like that. So that means the answer I'm getting here is plus or minus. Okay? The positive here and then the minus that I'm getting here. But the calculator is going to give you only the positive. Since the domain is given in radians, then you have to put your calculator in radians. Mine here is in degrees, so I'll press shift, then mode, and then I'll go to radians, which is option 4. And then we say the arc cos of 3 out of 5. Then this one is going to give you 0.927 to 3 significant figures. 0.927 in radians. 3 significant figures. That is that. Question 5. The diagram shows the triangle ABC in which angle ABC is equal to 90 degrees, AB is equal to 4 centimeters. The sector ABD is part of a circle with center A, and the area of the sector is 10 centimeters squared. Part A, find the angle BAD in radians. Okay, this one is coming from circular measure. How to find the angle BAD? Do we know this area of the sector is given here? And we know that area of sector is equal to a half r squared what? Theta. So the radius is 4. This one is 10. So we have a half times 4 squared, then times theta. So meaning this is 16 divided by 2, that is 8. So 10 out of 8 will give us the theta. By 2, 5. By 2, 4. That will be the value of theta. Okay, then next, part B. This angle is already in radians because to use this formula, theta is in radians. Remember, area of a sector. Area of sector, we get theta out of the 360 because you're having a circle and then there is an angle subtended at the center of the circle here by this arc, okay? Then times, so we are dividing by 360 because angles at a point add up to 360, or the total angle sum in the circle is 360. Then times, because the sector is just a portion of the circle, then I'll multiply by the area of the circle, which is pi r squared. But if theta is in radians, 360 is the same as 2 pi. So when I have pi here, r squared, this pi will cancel with that, and then you have a half, then the r squared theta. You see? So the value that I get for theta here is in radians. You see that? Okay, then next, find the perimeter of the shaded region. Perimeter, we look at the sum of all lengths around a given shape. So we have this BC, then we have the DC. Now, since this one is a right angle triangle, for any right angle triangle, you can use SOHCAHTOA or Pythagoras theorem. So I can use SOHCAHTOA because an angle is involved. This angle here is 5/4. Okay, so I can use SOHCAHTOA. Using SOHCAHTOA. SOHCAHTOA is used when there is an involvement of the angle in the right angle triangle. And then we use the Pythagoras theorem if we are dealing with only lengths. So using SOHCAHTOA, we have relative to this angle, BC will be the opposite. Then this is adjacent, not so? So tan of that 5/4 is equal to the opposite, which is BC, then divide by the adjacent, which is what? 4. So meaning the length BC is going to be equal to, you just cross multiply, that is 4 tan of 5/4. I can leave it there exact, then I round off at the end. Then also here, I can get this one here, okay? And then after I subtract off the 4 centimeters for AD, okay? So relative to this angle, this SC is the hypotenuse, and then this one here is the adjacent. So hypotenuse and adjacent are related by the cosine, not so? So we shall have cosine of 5/4. This one will be equal to the adjacent, which is 4, hypotenuse is SC, not so? Is SC, good. Then when we cross multiply, the SC is going to be equal to 4 because you are putting the SC here. Then after, you divide all through by this, not so? So that will be 4, then out of the cosine of this 1.25 or 5/4. You see that? Then next, what else do we have? We need to find our DC. So DC is going to be equal to SC, which is 4 out of cos 5/4, then minus 4. Okay, to get this DC, you get this whole SC, then minus this. Okay, then after that, we need this arc length here, BD. And arc length, you know that it is r theta. So we need to get arc length. It is what? DC? BD. BD is equal to r, which is 4. The theta is 5/4. And that one gives us a 5. So meaning now the perimeter of shaded region is equal to, we said arc length BD, then plus, there is BC, then there is also DC. So what do we have here? This one is 5, then plus, BC is 4, then tan of 5/4, and then the DC is going to be 4 out of cosine of 5/4, then minus the 4. So putting everything in the calculator to 3 significant figures, what are we going to have? Remember, the calculator has to be in radians. So we have 5, then minus the 4, of course, that will be a 1. So I'll just put 1, then plus. We have 4 tan of 5/4, then plus 4 out of the cosine of 5/4. Remember, the first 5 and the last 4, I subtracted them, and then I got a 1. So the answer is going to be 25.7. And the lengths were given in centimeters, so this one has to be centimeters. That is to 3 significant figures. So that is that. Question 6. Functions f and g are both defined for x being real and are given by these expressions here. But by first expressing each of f of x and g of x in the completed square form, express g of x in the form this one here. Okay, now if we are having, let's say, x then plus b, let's say squared, this one can be x squared plus 2bx then plus b, right, squared. And then I need this one to be having only x's, so I can take this on this side. That will be x plus b, okay, squared, then minus the b squared, which is equal to x squared then plus 2bx. Okay, this is going to be the same thing when, let's say, we put a minus here, or see here, okay, we shall have a minus here. So if we have x minus b, so when you say 2 times x times minus b, then you get this one as a negative, right? So even here we shall have that. Now, by looking at what we are having here, look at the coefficient of x, which is 2b, okay? This coefficient of x, which is 2b, is divided by 2 to give you the b. Now, do you see that it is put inside here and also here, then also here and here? You see? So you divide it by 2. So long as the coefficient of x squared is 1, then you get the coefficient of what? Of x. Then you divide it by 2, then you put it together with the x in the brackets, and then you pop it out as a square. So let us look at now the f of x. F of x here will be x squared. You get the coefficient of x here, it's a negative 2. So you divide it by 2, you will get a negative 1. Okay, then you square, then you pop this one out as a square. So always here we are having a minus. Why? Because this b crosses, and it is a plus here. Even here it is a plus, and then here it becomes a minus. You see that? Okay, now there is a plus 5 here, so plus 5. So this means that f of x is now going to be equal to x minus 1 brackets squared, then 5 minus 1, that one gives you a 4. And then what is g of x? G of x, we do the same, divide this by 2, you get a positive 2, so you get x plus 2, then squared, then pop this 2 out as a square, then we have that minus, and then there is a plus 13 here. Okay, so there is a plus 13 here, and then that means that our g of x is going to be equal to x plus 2. You see that? And then this is 13 minus 4. I think that is a 9. So plus 9. So that is what we are having here. So they are in the completed square format. And then they are saying express g of x in form of f. So that means there is a transformation there are some transformations which were done on the f to give you the g. Okay, now look at what you're having here. F of x, okay, is equal to this x minus 1 squared, then plus the 4. What did they do to this minus 1 to make it a 2? Did they add a 3? So they added a 3 on the x. That means we have x plus 3. Then I will have here x plus the 3. So where there is x, I'm putting x plus 3. Okay, then minus 1 squared, then plus 4. What do we get here? This one will give us x, then plus what? The 2. You see that? Squared, then plus the what? The 4. That is our f of x plus 3. Now, we have gotten this part for g. But now there is a 9, and this one is a 4. So, how do we transform the 4 to a 9? We add a 5, not so. So that means if we get f of x plus 3, and then you add a 5, then you will have this x plus 2 squared, then plus 4, plus 5, not so. And then this f of x plus 3 plus 5 is giving you the x plus 2 squared plus 9. This is our g here. So this simply implies that g of x is therefore equal to f of x plus 3, then plus 5. And that is that. Then part B, describe fully the transformation which transforms the graph of y is equal to f of x to the graph of g of x. When we are putting this one out, we change the sign. So this one is going to be a translation by vector. Here, this one will change the sign. You'll get -3, then what? 5. Okay, let me show you how that one comes about. So suppose I have this graph here, y, which is equal to, let's say, x squared. Okay, and then I get y, which is equal to, I'm going to get this x here. Then, like the other one, we are having plus 3 and then the 5. So I'm going to put plus 3 on the x, then I add a 5. So do you see that on this graph here that is produced, the blue one, so it has moved 1, 2, 3 to the left. So that is translation in the x direction, that is a 3, -3 in the negative. Then this one is 1, 2, 3, 4, 5. That is the translation vector. So that means when this one is popped from here and then it comes out as a negative. Okay, even in the movement of y, if you put this number here where y is, you'll have something like this, y minus 5, then is equal to the x, then plus the 3. But then we don't write this on this side. So when you take it this other side, it becomes a what? A plus. So that is why when you go back to our answer here, it has to be -3 here and then 5. If there is something added or subtracted on the x or y, that is a translation. Okay, then if there is a multiplication on the x or on the function, then that is a stretch. And then if there is change of sign for x and then on the y, then that one is going to be the reflection in either x or y. So this has been it for this first part of the paper. Thank you so much for watching. See you in the next videos.